Okay. So let's start. I'm going to go some slides fast, okay? Some slides, a little bit more time. Anyway, I'll try to finish and have enough time for like 4 presentations today, because so we don't move them to the later weeks. So if you remember last week, we talked about malicious codes. We talked about some categories, viruses, trojans, APTs, advanced persistent threats, and those we were talking, but we didn't talk about countermeasures. So we're going to continue today talking about malware countermeasures approaches and what we can do in order to be safe or protected. So the ideal solution for all these threats that we're talking, no matter what it's malware or whatever other threat is, the best solution or the first thing that comes to the mind or we need to do is the prevention. We need to make sure we are preventing all the malware threats before they affected us. So prevention is always the first step and the ideal way to do it, to deal with those problems. So there are some, prevention has got some elements. So it's important the policy that we have, okay, like a security policy that we are following. The awareness, the user awareness is important in order to make sure, how to say, that we are protected, okay. Vulnerability mitigation is important. If there are some vulnerabilities in the system that are known, it's good that we mitigate those vulnerabilities, and also threat mitigation are part of the preventions. But as we know, prevention doesn't solve all the problems always. No matter what we do, how much we take into consideration all the elements of prevention, still we're going to be affected one day or another by some malware or other security issues. So then it's very important after that happens, when the prevention fails, then we should be able to detect, identify, and then take action and remove the threats. So first prevention, then later we should make sure that if, malware could pass through the prevention stage, we are able to detect and identify and also then to be able to remove it. So talking about antiviruses, which is the first thing comes to our minds, talking about preventing against malwares. They changed a lot during the last decades, really. So the first generation of antiviruses, they were simple scanners, and they require malware signature to identify the malware. Basically, there is a set of there's a database of all the signatures, the known malware signatures that you enter into the database, and of course the database will be updated gradually, but you detect the malwares based on their signatures. So it's very obvious that you can only detect the known malwares, the malware that you already know, and or not you, but known by the, say, developing companies, and you have the signature in the database. The second generation was like heuristic scanners, which uses heuristic rules to search for probable malware instances. Like for example, one approach could be by integrity checking. The third generation was like activity traps, like where memory-resistant programs that identify malwares by its action rather than its structure in an infected program. So basically, the third generation was looking at the behavior of the malware, not simply like how it infects the program, but how the malware behaves in the systems, trying to detect by the behavior. And the fourth generation is basically fully feature protection, which means considering all the previous methods and combining all of them in order to detect the malwares based on their signature, based on the behavior, and like using, like, for example, integrity checking, using heuristic scanners, and so on. So let's say now we are in this stage. Okay, we have fourth generation malware detection or antiviruses that, even if you consider like all the AI like algorithms that will be used, I mean, you're using in order to detect, it can still consider a fully featured protection that can look at the behavior, okay, in a more advanced way in order to categorize the like malwares or detect them. So considering malwares, okay, we want to, as I mentioned, after the prevention, we need to be able to detect and respond to the threats that they are causing to the system. So we can analyze, okay, the malwares in two different ways, using a statistic analysis or dynamic analysis. In a static way, we attempt to understand what a malware instances would do if executed. And in the dynamic way, we attempt to understand what a program does when executed. Okay, so in the first one, in a static way, we don't want to let the malware run and then study behavior, but we want to basically predict what it would do, okay, if it start running. But in the dynamic approach, we let it run, okay. Okay, we're going to talk in what way, of course, in a controlled environment. Then we're going to analyze or study the behavior of the malware in a controlled environment after it's executed, so we can study or analyze the malware. So it can have different granularities, or like it can be like a different details. Okay, when we are analyzing the malware, it can be fine-grained or coarse-grained. Or for example, in fine grain, like automated unpacking, using automated unpacking tools to unpack the like a malware, or in coarse grain, like using very more detail, like tracking the malware behavior, like for example, checking the system call tracing and how they are used by the malware. So the most malwares that are coming out like every day, tons of them, they come out packed, okay? So part or all, part of, or some part or all of it becomes like compressed, encrypted, or transferred in one way or another. That's why when you look at it, okay, you will see like a, how to say, you don't see it like a executable code, okay, like machine code, okay. You see it more like a, how to say, meaningless set of like characters or codes, okay? Because they will use some encryption or compression techniques in order for antiviruses not to be able to basically get into them and know what is it basically, what the program is. And basically the reverse like encryption methods or the reverse compression method is hard-coded into the malware. So they will come basically packed, okay? And when they want to execute, they will automatically unpacked or uncompressed, and then they execute, or then they can be again encrypted, transformed in different fashions. So that's why, I mean, they are not always easy, and they are coming almost always packed, okay? But there are tons of programs that can help malware developers to pack or compress their codes to make it harder to detect. So we need, because the volume is a lot, okay? It's not just 1, 2 per month that we can analyze. So we need some sort of like automated unpacking tools in order to unpack and study the behavior of malware. So we can have like also like fine-grained tracing-based universal automated unpacking algorithms that detect the execution of codes not just in a static way, okay, but also looking at the system calls in more a dynamic way. So one tools can be sandbox analysis. Sandbox is a tools that most of you are already familiar with. So you can basically running a potentially malicious code in a very controlled environment. That controlled environment can be, let's say, even the virtual machines can be considered a sandbox or a controlled environment that you can run a code and study the behavior of the code. Or even the sandbox itself or different tools that just you can run it on your own operating system, but they emulate basically all the behavior of the operating system in a very controlled manner. They emulate like memory, CPU of like targeted systems. So you can then run that the code, the malware that you know or you want to study or you want to analyze the behavior in that controlled environment, and then study the behavior of the malware, like how it's behaving, what part of the system is trying to affect, how it's affecting, how it's transforming in a new generation, in a new versions, and also all sorts of behaviors. So running them in this controlled environment enables us to detect complex, encrypted, polymorphic, metamorphic malwares. You remember we talked about these things last class, that basically there are malware that they rewrite themselves in each iteration in a totally new way. So it makes it hard for antiviruses to detect them easily. So unlike heuristic or like that fingerprint-based scanners that, like, let's say you can run, you can have like host-based behavior blocking software, okay, that they can run or they can integrate with the operating system of the host computer, okay, and monitor program behavior in real time for malicious actions. So what they do, they don't look at just the fingerprint, they don't use heuristic methods, but they basically let the basically malicious code run, but then they start, how to say, they try to block all the like a damaging action that a malware is trying to do. Okay, so that I don't know, those actions can be a lot of things. For example, if the let's say the malware is trying to remove or like format a removable disk in your systems, or trying to change your startup settings, trying to include some executable in the startup of the operating system, or trying to do like changing the logical part of another executable files, trying to change some critical part of your operating system. So those behavior can be detected and can be blocked by behavior blocking software, which they don't just rely on the fingerprint or on the signature of the malware, but more on the behavior, how this like executable file behaving in the system. Is it behaving like a suspicious way, or is it behaving like a normal way? So that can be another way, but it has its own limitation, of course, because malicious code must run on the target machines before all the behavior can be identified. It can cause, of course, harm before it has been detected and blocked. Because you have to let them run in order to see their behavior, but because you let it run, in some case, they can already start damaging before even you detect the behavior. So that's just another manner to do that. But just remember, we have so many different ways: checking the signature, studying the behavior of the program, how they're behaving, their signature, of course, if they are already known, or by any like how to say, if the signature is already known, if their behavior is suspicious, or then you can mix all these things, okay, with a fully, how to say, with an antivirus that can consider all these parameters at the same time. Let's say using a certain machine learning algorithms to do it more effectively. So that's it. That's all about malicious code. I want to close by talking about some prevention also schemes, not just talking about different types. Any questions so far?
So these are ways in which we can avoid malicious code. And not, I didn't understand if it was like tactics to avoid malicious code or it was the behavior of the malicious code itself.
No, it was not tactic to avoid, okay? I didn't talk about this. I talked mostly about this here. I mean, the main idea is to, I mean, of course, you try to avoid this too, okay? You're trying to prevent, let's say you have antivirus in your system, okay? But the antivirus in your system, they detect it when it's already in your system, right? Usually they detect it when it's already in your system, or it's affected some executable file, and they detect, oh, this file is affected. So let me clean it, or if I cannot clean it, I'm going to delete it. So it's a mix of both, but not just prevention, more like also detection, identification, and removal. How you're detecting them, how you're identifying them, and what action later you take, right? But for prevention, there are other ways that we're going to talk right after this. Any other questions? So let's talk about firewalls. Okay, so now a method of prevention. Before even not just about malware, but about all sorts of other attacks that we want to avoid. So firewalls are part of network defense in depth. Defense in depth basically, I'm confused with Spanish. It means adding different layers or several layers of protections, not just doing one thing, okay? So we're going to talk about firewall filtering and some deployment strategies. So so defense in depth means like having different layers of protections, okay? Not just considering one thing. So you want to have different layers of defense mechanism. So I already, in the last few slides, I already mentioned what is the first stage for the defense in depth, or for defense, for being safe.
Prevention? No.
Yeah.
Not yet? Oh, I thought it was awareness.
No, the prevention is the first stage. I mean, the first stage you want to prevent, right?
Okay.
The first line is a prevention mechanism to stop all sorts of attacks from getting into the network and later into the system. So you want to prevent. So you want to basically block all the holes, all the weaknesses, all the ways that basically put our system in danger. So you want to prevent. The next stage is, you already talked?
Aware, right?
Pardon?
Aware, right?
Aware?
Awareness?
Yeah, you can look at it that way. You are detecting or being aware that it happens. After, I mean, they pass through the prevention, then you want to be able to detect them, right? Because if they pass, you don't detect, you're doomed, right? It means your system is affected, you are not even detecting that. So it's very important after it happens, then you'll be able to detect, and of course, at the last, you want to survive that problem. You want to, if it's a malware, you want to get rid of it. If it's a intrusion to the system, you want to block that access from intrusions. So you want to survive at the end. So remember, prevention, detection, and basically surviving, okay, or like a removal of that, how to say, the intrusion. Okay, that's the best. So let's talk about the preventions today, about network preventions. So we're going to talk about firewalls. I mean, you already know about it, but maybe we can talk about it a little bit more in details. So it's basically widely used prevention schemes is the firewall. The most known for us, and the most used one is the firewall. So let's say this is an enterprise network. It can be a financial enterprise, it can be any type of enterprise, educational, NGOs, whatever it is. It can have some structure like this. We have some trusted network part. Let's say if it's a financial institution, okay, you have your trusted network part, which only certain users from your organization are allowed to access this this trusted network part. Let's say if it's a bank, then it would be all the servers that keeping track of your accounts, the how to say the balance and all those financial information in a trusted network part. And then you have also some DMZ or demilitarized zone, which are like part of the network that are accessible for publics. So what it can be your domain, okay, if your financial system, your website, your domain, and all the related files for that, it can be in a how to say in DMZ or demilitarized zone, or you can say like call it public accessible servers and networks. Of course, you will protect your trusted networks by firewalls and as well as your DMZs. But this is the firewalls. Okay, if you see this fire thing, this is a firewall. But the difference here is you can have even the firewalls inside the servers themselves in your trusted networks. And of course, users, trusted users, untrusted users, both are trying to connect to your network using internet, either access your, trusted users access your maybe, how to say, DMZs, untrusted ones trying to get into your trusted network and basically extracting some useful informations. So the firewall is the one that basically providing the security for our network. So we want to talk about firewalls or focus on firewalls and see what we can talk about it. So if you remember, once we were talking about information, those like 2-3 weeks ago, we were talking about your security policies. Then after you have the security policy, we said you need to enforce it. You remember we had this example of tech and the gates. You say this security policy is only tech people get into the campus, employees, students, okay, or parents if they, or I'm not parents, visitors if they pass through the security. Then that's your policies. Now, if there is no security guard, if there is no wall, you cannot enforce it. Now you need the walls, you need that security guard, the scanners, all those things in order to enforce your basically security policies. So you can say firewalls works the same way, okay? So all the traffics, the firewall, all the traffic must from the internal network to the internet and vice versa, from internet to your internal network must pass through the firewalls. So it's both way, basically information transfer from outside to the internal network, from internal network to the outside. And you want only the traffic authorized by the policy to pass through your firewalls. Basically, that's how you're enforcing. And of course, if you remember now, it's like you're saying all this basically traffic should pass through the firewalls, okay? So it makes it how to say, a single point of failure. Imagine if you cannot trust it, like now trust the computing base that you were talking. So it is not, firewall is not TCP, okay? Don't confuse. I'm saying that that's because all the traffic is passing through the firewall. So you want your firewalls to be immune to subversion. You don't want basically someone be able to modify it, disable it, or do whatever with your firewall. It should be working properly. And you should also be able to trust the firewalls because your all traffic is now passing through the firewalls. So another things here, like I'm saying, like the two, all traffic from internal network to the internet and vice versa should pass through the firewalls? Why our traffic from internal network to the internet should pass through the firewall? Of course, it's perfectly makes sense. Traffic from the internet to your internal network should pass through the firewalls, right? So why it should be also from the inside network to the internet?
Well, it sounds pretty clear. I mean, in the way that you are protecting your data. So basically, if people is requesting some data that shouldn't be outside or made public, you should be aware of that and block it and protect your data.
Yeah, exactly. You're right. That's not all the reason, but that can be one reason. You don't want a certain set of traffic to start moving out from your internal network to the internet. Or another reason can be maybe your antivirus, not antivirus, your firewall detecting that there is a botnet is activated in your internal network. Of course, you want to start blocking that, like the traffic that is generated in the botnet inside your network or some computers that are involved in that from internal network to the outside network. So specifying a suitable access policy, okay, we already talked about access policies before. So specifying a suitable access policy is very important. Basically, it can be a critical component for planning and implementation of your firewall policy. So this can list basically the type of traffic authorized to pass through the firewall, include address ranges, certain IP ranges, depending again what sort of basically requirement how to say a network has. You may want to include a certain IP range, certain protocols only, certain applications or certain content types to pass through your firewalls. So this policy should be developed from the organization information security risk assessment and policy. Of course, it's very much independent. Maybe a financial institution totally requires different set of, how to say, policies comparing to like educational institutions or comparing to medical institutions. So there are totally different requirements for each different type of basically organizations. So it's not just one set of rules to take care of everything. And it should be developed from a broad specification of which traffic type the organization needs to support. Again, it makes pretty much sense. I mean, if you are a financial institution, there are certain traffic type that doesn't make sense at all to pass through your firewalls, right? Or if you are even an educational institution, certain traffic type doesn't make sense to pass through, let's say. So then you want to refine the detail and filter, define the detail, the filter elements, which can be implemented within an appropriate firewall topology. So you have to know basically the organization information security risk assessment in order to come up with your suitable access policy, and then carefully set that firewall access policy with those requirements. Firewall capabilities has certain limits and advantages, of course, capabilities and limitations. We already said all the traffics from the internal network to outside or from outside to internal network should pass through it, so it make it a single choke point. This single choke point actually it can be the capabilities because you have a single choke point that all traffics pass through, and then you can start analyzing them. You can start, studying that traffic. Okay, you can do a lot of things for that reason, because there is only one single point that managing all the traffic. And you can provide a location for monitoring security events based on the traffic that passing, or even that make it easier, of course, for us to set our policy in just one point, right? And take care of all the traffic that's passing through. And it's a convenient platform for several internet functions that are not security related. But it can also provide extra security features for the security, for non-security related internet functions, like say, for example, for address resolution protocols, okay, those can be helpful. But it has the limitations. It cannot protect against attacks by passing firewalls. So if the attacks bypass the firewalls, they cannot detect it. And how it can happen, let's say, consider the situation that we are living now. We are working from outside, okay, so I need some sort of access to the tech resources, to the server in tech, to run my certain algorithms or my programs. So they might assign a way for me to bypass that, let's say, the default firewall setup, okay, now that I need to access it from outside. So that can basically put the network in risk. Just one example. It may not protect fully against internal threats. Of course, it doesn't fully protect from the threat that's happening inside the network. So improperly secured wireless LAN can be accessed from the outside organizations. If you didn't set up your firewall properly, the policies, the network can be in danger. And also, last but not least, laptop, PDAs, portable storage devices may be infected outside, taken into the inside, and then infect your system. So it's basically a traffic not passing through the firewall, but I'm carrying it in my pocket, right? The infected files, I'm connecting to my laptop or my computer in the classroom or in my office, then that's how I infect the internal network. It's not some basically threat from outside, but it's an insider that taking the infected file or the malware inside the systems. And that's actually where a lot of big threats for financial institution, for military institution, for big things, that's how it happens actually. I mean, people taking the malware inside without even noticing. So, of course, firewalls, accessing all those things that we are talking about using filtering mechanism that it has. And basically what it does, it checks all the packets that passing through it, and either it allows them to pass or it doesn't allow them to pass, all the packets and all the traffics. And it affects inbound and outbound traffic, either from inside network to the internet, or from internet to the inside network. So basically seeding between your internal and external network. So how that basically filtering can happen based on different policies. For example, you can filter them based on the IP address and protocol values. You can filter them based on the application protocols. Okay, for example, you can assign like application level gateways that relies and monitors the exchange of information for specific applications protocols, or based on the user identity. Here, you typically for inside user who identify themselves using some forms of secure authentication technologies, or for network activities, where control access based on considerations such as the time of the request, rate of the request, or other activity patterns. Based on all those things, you can start filtering the traffic, IP address and protocol values, application protocol, user identity, network activity. So because at the end, you have to set certain policies in order to study the packets and let the packet pass through or not pass through. So let's say for packet, let's talk about these two types, like packet filtering and session filtering. In packet filtering, you have basically access control list. And these are the two main basically type of filtering, packet filtering and session filtering. For packet filtering, you need an access control list. We already talked about access control list when we were talking about authorization or access control. And another is session filtering, it requires dynamic packet filtering, stateful inspection, context-based access control. So in the packet filtering, what you do, you just look at the packet itself. So you start inspecting each single packet that's coming through or passing through the firewall, and you're inspecting the packet, okay, and you decide based on the content of the packet. So there is no state information saved. You don't have the state of the connections. You're just making the decision based on the packet, each packet. So as I said, you apply the rules to each incoming and outgoing packets, okay? So typically a list of rules based on matched in the IP or TCP headers. For example, you said you allow this set of IPs pass through, okay? Or this set of TCP headers pass through, and then you check each packet and to make sure it's falling in that requirement, then you let it pass. So you can have two default policies, either discard, okay, or prohibit unless expressly permitted. And forward, it means permit unless expressly prohibited. Basically, in the discard policy, you discard all the packet by default, unless the packet is specifically permitted to pass through. In the forward, you forward all the packet unless it's explicitly forbidden. This is the thing that we talked a few times so far in different examples, okay? Of course, this one is more conservative, controlled, and it's visible to users. And it's, of course, this is more secure because by default, you're discarding the packet, unless specifically you're permitted certain packets. The forward is less secure. It's easier to manage and use, but less secure, as I mentioned, because by default, you're permitting all the packets to pass through unless explicitly they are prohibited or they are blocked. So of course, this is less secure than this one. And the decision can be based on like source IP address, destination IP address, source and destination transport level address, IP protocol feed, interface, or all of them together you may consider. But your access control policy can be something like this. For example, you have the rule, you have the direction, inbound traffic or outbound traffic. You have the source address, destination address, you have the protocol type, destination port, then your action that you're taking. Just a very simplified, let's say, access policy, okay?
That was the first policy, the example of the first policy.
I didn't get your question.
Can you go back in one slide? And then is that like the forward permit rules?
You mean this is the discard rule or forward rule?
Yes, exactly.
So this can be a forward rule. Oh, this, okay, no.
Okay.
No, it's not precise like that. If you're permitting, like you're saying, if it's coming from, basically, if it's an inbound traffic, okay, it's coming from the source address is external address and the destination address is the internal address. And the protocol type is TCP and destination port is this, then permitted. So I can say it's a discard. This particular one is like discard, okay?
Okay.
Because or if you look at all these things at the same time, it's like a discard policy still. You're allowing certain policies, okay? Or no. The important, sorry. The important one is this one, okay? You're saying only permit this one, okay? So this is discard policy for sure. You're saying only permit this one. If anything else doesn't fit in this category, so you discard it. So this is a discard way. Because you just basically you just allow, okay, or you prohibit only expressly permitted. Or basically you just allow those that you want to pass through, okay? And you discard anything that doesn't fit in this category. So you're discarding everything else. So it's a like discard policy. It's clear?
Yes, now it's more clear. Thank you.
So it can be like example, a simplified example. But there is like, you can be even more specific than this, okay? This is simplified, it can be still prone to some problems. For example, like consider this rule, the for that we have it here too, okay? Here, and we are saying permitted, but here now we have a basically source protocol and some acknowledgement. So the acknowledgement field here, okay? You're saying basically if that protocol, if that packet is coming as an acknowledgement to another packet, permitted, otherwise unpermitted, okay? So you're adding basically another conditions, because just saying it like this, it can start some, how to say, vulnerabilities in the packet because you're not checking all the required field. Because like the problem is start from the port. You're saying if destination port is anything bigger than 1023, permit, okay? But destination port can be like a, how to say, a big number, or different protocols can use a higher port number. So talking about packet filtering, it has advantages and weaknesses. The advantage is its simplicity, and it's transparent to the users and are very fast because there is no extra overhead on the network to check anything else. You just look at the packet, look at the headers, you let it go or you drop it. And the weaknesses is it cannot prevent attacks that employs application-specific vulnerabilities or functions. It has limited logging functionality because you're just taking care of one packet at a time. So you don't consider the whole set of the packet that can be considered data segment. They do not support advanced user authentication, vulnerable to attack on TCP/IP protocol bugs. Improper configuration can lead to data breaches. So it's not that safe. You just consider one packet at a time, because if, let's say just one certain malware can be extended to several packets, okay? I mean, each packet can be like look like legitimate at that just by considering the packet, but looking at the whole data can be basically give you more information. So there are some countermeasures, okay, for packet filtering firewalls. One is IP address spoofing countermeasures, which discard packets with an inside source address if the packet arrives on an external interface. So what you can do, you can spoof the IP address and make it look like the packet is from the inside network to inside network. Or you can change the IP address of that external IP address to an internal IP address. Or source routing attacks countermeasures, where you discard all packets in which the source destination specify the route. Oh, sorry, I'm talking about the countermeasure. Okay, so basically you're discarding the packets with an inside source address if the packet arrives on an external interface. So if the packet arrives in your firewalls with an internal IP address, you just discard it because it can be a malicious packet. So if the packets have the source and destination very precisely mentioned, okay, the source and destination route, if the packet is telling you that from which route it's going to, basically it's very well specified, it can be a fishy packet, so you can discard it. And another attack can be tiny fragment attacks where you don't include all the TCP headers in the packet, in one packet, okay? All the required TCP information, you don't include it. You extend it, you break it down in multiple packets. So each packet by itself can look legitimate, but the complete one can be basically suspicious. So in order to do that, you can enforce a rule that the first fragment of the packet, because when the packet is big, you're going to break it down and send it in multiple packets. So you can set this rule that the first packet should have the predefined minimum amount of the transport header. So you can make sure this transport header basically is safe to pass because it has enough information. So another one is stateful inspection firewalls, which is not just per packet, okay, but it's considered also the state of the connections or state of the basically connection that established already in your system. So the packet filter was like this, okay, you're just looking at the transport layer, let's say informations in your TCP header and deciding based on that. But the stateful inspection has the state information of the specific connection state that is already established connections. Again, I can continue with this. So talk about that the stateful inspection firewalls is so you have one entry for each currently established connections. For example, you have a established TCP connection between two different applications. Okay, in your internal outside network, it's an established connection and they are communicating with each other. So you can keep that state information into account when you are trying to deal with the packets. Okay. And that can be basically another information for you to consider if the packet is legitimate. It's coming from this IP address to this outside IP address to this inside IP address in a connection that is already established in established TCP connections. So the packet filter will allow incoming traffic to high number port only for those packets that fit the profile of one of the entries in this directory, your established connection directory. So basically what you do, you keep tracks of TCP sequence numbers to prevent attacks that depends on the sequence number. Or like you can see here, for example, this example, you have the source address, you have the source port, destination address, and destination ports. And what is the connection state for this connection between these two ports, these two IP address and these two ports. If this is established, so you can let the packet pass. If it's not, you can basically drop the packet. So far we talk about basically packet-based filtering, just looking at the packet, a stateful firewall, which look at also the established connections. So those were basically more like a, let's say, lower layer firewalls, considering like a transport layer, also related to the physical layer or, that keep the state of the information. Also, you can have a application level gateways, also called application proxies, which sit on the application layer of the network and act as a relay of application level traffic. So the application level gateway can look like this. The user contact the gateway using, let's say, TCP/IP applications. So let's say it can be FTP, it can be like Telnet or any other applications. And then the gateway request name of the remote host. Then the users basically provide the valid application information for the gateway. The gateway contact the application and relays TCP segments till basically all the for the application level in order to monitor all this information in order to decide if this connection or this packet, not the packet, then if this, yeah, so the packet should be basically passed through or should be dropped. So the application level gateway must have proxy code for each applications. So it may also restrict application features that is supported. So for example, talking about FTP, okay, maybe it's for FTP application, it doesn't just support the FTP, but it supports like secure FTP, okay? It can limit also the features that it's supporting, not FTP, but secure FTP. It can, for example, limit itself to secure FTP. So it's tend to be more secure than packet filtering because it can be more adjustable. It's more like flexible also. The disadvantages is additional processing overhead on each connections because it's sitting on applications. I mean, that's a general rule. The lower level you start like meddling with the network packets, it's a less overhead. The higher level you go, there is a more overhead because it's application level gateway. So there is more processing overhead on each connection. So it can slightly affect basically the performance of the network. So talking about that, let's introduce this concept of the bastion host. It's a system identified as a critical strong point in the network security. So typically the bastion host is the servers, okay, or platform for an application level gateway. And it has some certain common characteristics. It runs a secure operating systems, only essential services, or if you can consider it run an hypervisor that we already talked about, which is not a fully functioning operating system, just having the essential part of the operating systems. So it may require user identifications to access proxy or host. Each proxy can restrict features, host access. Each proxy is small, simple, and checked for security. Each proxy is independent, non-privileged, and it has a limited disk use or like read-only code only. So basically, the only thing, let's say, if you know about this, if you heard about this terminology, bastion host, is a critical strong point in the networks, okay, where you can basically developing your application level gateway. It's important, it's a critical strong point because if it can be bypassed or it can be modified, then basically all your security structure will collapse because that critical security point is already broken and you cannot trust it anymore. So far, whatever we talked about, like network-based firewalls, the firewall that sit on the network and try to filter all the packets coming through the networks. Okay, it's not just a firewall sitting in my laptop on a server. It's usually there are hardware-based firewall sitting on the network. But we can have also host-based firewalls. Let's say the firewalls that we use in our systems, okay, in our personal system, personal computer, can even be on a server. So it does use to secure an individual host, not the whole network, okay? And they are available in operating systems as a like internal functionality or like some add-on package. And they filter and restrict packet flows and usually they can implement on the server. They can implement also on a host as well. I mean, single computers. And the advantages they have, the filtering rules can be tailored to the host environment. So it's not like now you're trying to filter all the network traffic, but you can basically adjust it or tailor it to exactly what this particular server or this particular host requires. So the protection is provided independent of the topology of your network, and it provides an additional layer of protections. No matter if you have also a network firewall, you can also have a host firewall as an extra layer of security. And personal firewall, which like a host-based firewall, can sit on a personal system. So it can be a software module, it can be add-on your operating system as well. It can be housed in a router as well. Like if you have a secure routers, or some routers have security features, like internally in themselves. They are typically much less complex than like host-based or let's say network-based firewalls. And their primary role is to deny unauthorized remote access to the network. So some firewalls can have this stealth mode that hides your system from entire network. Okay. So in order to basically, it provides how to say the stealth mode. The stealth mode, I mean, the name is like self-explanatory. It explains itself. I'm not like pausing or giving break because I'm almost done, like in 2 slides. Okay, let me finish, then we can have break, then we can have presentations. So in order to deploy the firewalls, now that we already talked about the network-based firewall, host-based firewall, personal firewall. So if this is your network, okay, you have the internal protected networks. Of course, they are all connected to the certain LAN switches. And at the end, you're connected, all your network connected with the like the routers to the internal network or internet. So you have the internal protected network, you have internal demilitarized zone network, which is publicly accessible part of the network. So your firewall can be set like in different layers. You can have one firewalls for your demilitarized zone and then another firewalls for your internal protected network. So you can basically add in different layers of security. So those internal firewalls can provide like strict filtering capabilities, two-way protections for, as I mentioned, internal inbound, outbound traffic, even for your DMZs. And multiple firewalls can be used to protect portion of the internal network from each other. So even here, you're protecting your internal protected network from your internal DMZ networks. So basically, if this part of your network want to access the basically more secure part of your network, should have passed through these internal firewalls. So, and you can have a distributed firewall deployment. Okay, let's say like in this case now I'm a remote user. I have a personal firewalls. This is the web server in my external DMZ network. It has a host-based firewalls. Then I have to pass through these external firewalls in order to reach these internal DMZ networks. Then I have to pass through the internal firewalls in order to have access to the internal protected network, reach all those servers again protected with the host-based firewalls, and all the workstation are provided with like a personal firewall. So it's like a firewall everywhere. Okay. So you can have a different level of basically different level of security, and that's basically what actually happens, right? You have a firewall in your system. Maybe your router even has a certain firewall capabilities, then you're connecting to your company's your network. Okay, most probably you're passing through some certain external firewalls that's controlling all the traffic of your network, internal network. So that's how, let's say, it can be basically in a real world scenario. Any questions about this? I know I went so fast in some part, just to finish. But the takeaway points, okay, are knowing why we are using firewalls, so we know it, but knowing how we can detect basically how we can stop unwanted packets, unwanted access to the network, how we can look at it, and what type of firewalls we have. Basically, I think that's all you need to know. I mean, you need to take away from today's class. So it's basically a tools to enforce security policies. We have security policy, now we have to enforce it. So we use firewalls in order to enforce them. So we can have packet filtering, we can have station filtering, we can have application level gateway. We can have host-based firewalls, network firewalls, screen routers, bastion host, which is your secure part of the network, and also we already talked about demilitarized zone of the network, which has your publicly accessible part of the network, and also more like internal, how to say, secure part of the network that can be separated with an external firewall. Any questions?
Everything good.
Sorry, I went too fast because I don't want to cut it in the middle, go like for a slide for the next week, so we can finish with this, because it's not really complicated topics here. More knowing about the concept of firewall, how it's filtering the packets, where it's sitting in the network, and what type of firewall we have. Basically, that's it. So we can have a like 5 minutes break and we come like 4:45. So we can have three, 4 students presenting. Okay.
Mari, I'm gonna be honest, I totally forgot about the presentation. I didn't want to rush a presentation while you were presenting, so can I do it next class?
Sure, it's okay. We have already, actually it's kind of better because we have already 3 students. Okay.
Okay, perfect.
So we move yours to the next one.
Thank you.
No problem. Okay, so let's come back like 4:46, around that.
Teacher,
Yes.
if I already have my topic for my presentation, I'm the number 17. Do I tell it to you so you write down the name of the topic?
You can text it me here. I can write, or you can edit it yourself.
Okay, it's about Metasploit.
Which one?
Metasploit. Let me check it.
Can you type it for me in the chat?
Okay, I can write that on the chat.
Okay, thank you. Yeah, I mean, this is, by the way, this is editable for everyone.
It's already on the chat.
Okay. Oh, okay. Oh, okay. It was good. You are number 17.
Yes, that's right.
Okay, so I started and I wanted to do some research on some famous hackers, and I found this name, Kevin Mitnick. I don't know if you guys know him, but he was like, well, I will explain what he did later. But like when I was trying to research about him, I found a term that I didn't know, that is dumpster diving. So I actually like kind of changed my presentation to dumpster diving because I liked it, and well, since I've never heard of it, I hope like this works for most of you, like you can learn something. Okay, so dumpster diving is a kind of legal hacking that can be like done in multiple ways. What it is like going through the trash of someone and taking out files or things that matter to them. This can be done like in computers, like from scraps, or if someone finds a hard drive, they usually like try to recover as much as they can, and sometimes there can be like maybe stored passwords or stuff over there. So that's what dumpster diving is. The most famous example was performed by a guy named Jerry Schneider in Southern California. He was in high school and he found out documentation regarding Pacific Telephone's automated equipment. Well, what he did was like he found something that most people thought was trash, and he had some codes over there, and he changed the delivery to his place. So he ended up like stealing lots of equipment, but it wasn't stealing because the company had it delivered to him, and like they found out when he was like kind of selling the same equipment, and he actually sold it to the company. That's like the biggest dumpster diving case there has been. Our guy Kevin Mitnick, he actually did dumpster diving too. What he did was he asked for I think it's over here. Okay. So he went to a bus and he asked the driver if he could have a ticket checker for a school project. So the bus driver actually gave it to him, and like he thought it was like nothing like too valuable. And what Kevin did was he applied it to make his own tickets. So he started selling tickets, and he actually rode the bus for limited times with no money. And like going back to Kevin Mitnick, his first hacking was he gained out unauthorized access to a computer in 1979. He was barely 16, just by having the phone number of a company called ARC, which did a computer equipment. So he gained access and copied all the company software, and he actually used it just like as he didn't like use it bad, but he had all the software of a company who made billions of dollars. And well, actually he got in jail, but like this guy is famous because he's very controversial because of all the things he did, and some people say like he actually shouldn't deserve to be in jail. Right now he runs the Mitnick Security Consulting, and which like helps companies to make their software safer. Any questions?
Any questions?
No.
I have a question. I wanna see how well you researched. Okay.
Huh?
I wanna see how well you researched. Do you know that no before?
I couldn't hear you, sorry.
I mean, do you know no before what it does?
No before?
Mm-hmm.
Oh, this no, I didn't.
Okay. Okay. We didn't do that throughout research, again, deep research.
Do I stop sharing?
Yeah, okay. Then yeah, stop sharing. And no, before is it's a phishing basically company that they I mean provide the services for different organizations to run like phishing email campaign in order to educate their employees that if they are aware of the phishing emails, that's actually what tech uses in order to train its employees using that services no before. Who else? Eduardo Alonso? No? Maximo, you're here?
Yes, I'm here.
Okay, you want to share?
Yeah. So, okay. Do you see the presentation?
Yes.
Okay. So I'm going to present man in the middle attack. First, what is a man in the middle attack? Well, these attacks first requires 3 individuals. The first one being the victim, the second one, the entity which the victim is trying to connect, and the last one, well, the man in the middle. So in this attack, the man in the middle intercepts a normal connection between the client, in which is the victim, and the service is trying to access. What it does is fake a normal connection between them, but he's actually controlling the flow of the information that it's being exchanged. So in this image, we see that the normal flow is a client makes a request and the server responds, and again, a request and response and so on. So in a man-in-the-middle attack, well, the direct connection between the client and the service is broken or practically non-existent, or it never happened in the beginning. Okay, sorry. So what the man in the middle is trying to do is fool both the client and the service making them believe they are interacting with each other. So one of the keys for this attack to be successful is that the attacker must impersonate sufficiently both the client and the service. So like fulfilling their needs. So to make an example, if you're going to a website, let's say Facebook, and the attacker intercepts your connection and shows a login page with the components that should be blue with red, well, the victim is going to find out that that website is not legitimate because, well, we know Facebook doesn't use the color red because of brand policies. So that's what I mean with satisfying like the needs and impersonating both the service and the person. So let's go to some example. This image, it's an example of a simple attack. It doesn't mention the means that the attacker used to make it, so it's just to illustrate. So we have 3 individuals. We can say Jack is the victim and Jill the entity he's trying to connect, or vice versa. And Peter is the man in the middle. So we see that Jack sends over his key, but as Peter intercepting their connection, he actually sending his key to Peter. So Jack sends his key to Peter, and Peter sends it back to Jill. So now Jill sends back her key, but as Peter intersected their connection, he's actually Jill is sending it to Peter, and Peter sends back to Jack his own key. So Jack, thinking that he has a secure connection and established connection with Jill, sends his account number, but as Peter, as the man in the middle, tricks the number and changes it to his own bank account. So now Jill goes and deposits money to the wrong bank account, and this ends the man in the middle attack. So Some common types of man-in-the-middle attacks are DNS spoofing, which practically the attacker forces the user to a fake website than the real one that well the user intended to visit. We also have SL hijacking, which the attacker uses another computer and a secure servers and intercepts well the information passing between the service and the user. We also have email hijacking, but in this one, the attacker, what it does is gain access to the email account of an entity or an enterprise. And what it does is, well, it's most commonly for banks and sends the entity's customers instructions to follow, like deposit money or change a password, etc. Then we have Wi-Fi eavesdropping, where the attacker will set up a Wi-Fi connection that have very legitimate sounding names. And so when a user connects to this Wi-Fi, well, the attacker will be able to monitor all the user's activity. And the last one, we have stealing browser cookies, which our classmate Diego Cardenas, I think, made a demonstration like a few classes ago, where basically the attacker can obtain your credentials by stealing your browser cookies. So some tips for avoiding man-in-the-middle attacks are always make sure that the pages you are visiting use the HTTPS protocol. If you didn't know, the S stands for secure. Then manually type the website address into your browser. This is more for like suspicious email. Instead of clicking on links that in the emails, with the emails that came, go directly to the company's website or the entity's website. Like Santander, when they notify you that it's time to change your PIN or your password, they instruct you to do so through the application, not through any email they send. And the last one is to never connect to a public Wi-Fi routers directly. If you have a VPN, then use it so because the VPN encrypts your connection. Or if you don't have a VPN, then before you connect to a Wi-Fi, a public Wi-Fi, clean your cookies and never log in or use your credentials of any kind while you are connected. And that's all.
Thank you, Maximo. Any questions from students?
Okay.
Okay, thank you. Thank you. Okay, Eduardo, you're not here now. Eduardo Alonso. He's not, that's fine. Alejandro, you are not ready, right? Alejandro? Parra?
Correct.
Okay. So we're still missing two. Okay. So since we have time, okay, let's do something. I mean, just in parentheses, that the people that you're missing your slides, I would consider that on the grading, okay? Just to be fair, okay? Let's do this question, if you're there. You see my screen?
Yep.
You see the cover?
Yes.
Okay. So this is like a 12-13 question about the malicious code. So let's see.
Teacher, does this count for points?
Pardon?
Does this count for points?
Yes, let's see.
Like an activity?
If I say no, like no one's gonna do anything. Like you're not gonna even try.
Oh, I would try to take it seriously. I just wanted to know because of the name.
No, it's okay. More? Imagine that when open will send several people. So trapdoors, why majority select the trapdoors? Sometimes they might be like arguable. If you can argue, we can argue about it. Maybe you say it's a logic bombs because something initiated the attacks, right? Anyone wants to argue his wrong answer?
Well, I thought it was logic bomb because it gave a condition for the virus to send to the user's address books. And so I thought that the condition automatically made it a logic bomb.
Yeah, it's a valid argument. Yet, we'll attach that when open, will send it to all people in user's address. Yeah, it can be sort of considered as logic bombs, but still virus is much better answer. But yeah, I got arguments, but it's not a Trojan horse. It's not a trapdoors. Let's go to next.
El experto.
Vámonos.
Yeah, it's a Trojan horse. Anyone wants to argue, or
I think it's, well, I answered Trojan horse because it's something that is disguised as something else, but in the background it does malicious things.
Okay, I kind of get why a lot of people picked trapdoors, because you assume maybe it's like a legitimate software, right? That there is a, basically it does this functionality, but there is a trapdoor that I can read the user input, something like that, right?
Yes,
But
that's basically why it's
Sort of.
trapdoor. Yes.
but it's more like a Trojan horse. I mean, again, I get the confusion. I mean, that could be seen as like a trapdoor, but again, another thing to consider is a trapdoor is like you have like a backdoor to access a certain systems, right? But if it's a customized keyboard that logs your user input, basically it's a Trojan horse that's considered look like something useful, but actually is something. It's a Trojan that's stealing your information. So a Trojan horse is the right answer.
No.
Okay.
We'll get it right someday, teacher.
No, it's not always. It's not necessarily your problem. Actually, if there are like controversial questions that can really look in two different ways. Okay, best
Yeah,
to
this could
find
be.
an employee, but honestly, here I agree with your answer. Trapdoor is it's a best tools. Okay, let me see why I put Trojan horse.
I think like Trojan horse is easier to like convince people to use it, but the trapdoor, like you have to have some way to manipulate the software of the company, and that's
Yeah,
not that easy. So
that's a
Trojan horse,
good
like you
argument.
can.
I mean, my perspective was like the company was spying on me. So that's why I choose trapdoor.
Okay. It could be that one, but the best one can be Trojan horse. Maybe the most effective one can be trapdoors, right? But not that best or the easiest one. I don't know.
You
Let's
can
say
put
both
more than
correct.
one answer, teacher.
Yeah, I know. I mean, but I thought it's like Trojan horse is the best, but let's say agree with your answer. But if it comes to quiz, I try to be more like clear, you know, exactly. So it won't make any confusion. It's more confusing.
I think we're gonna get it wrong again.
Yeah, that was good. You got it, Victor. I mean, I don't know you, but majority got it. So logic bombs was the best way. So why, who picked logic bomb? Why you think it's better than virus?
Because when the intention is crippling and basically disabling the system, a logic bomb tears it down from the inside, basically.
Yeah, that makes more sense, right? Okay, let's go to the next one. you want so bad that trapdoors to be correct, right?
One day, trapdoor will be the answer.
Someday, teacher, someday.
One day to be the answer. But trapdoors, how trapdoors can spread information? Come on. How trapdoors can be the best way to quickly spread information and drive traffic to a specific website? No,
Sure, it's because when in doubt, trapdoor.
How?
When in doubt,
When
like
we're in doubt, trapdoors.
yes.
Yeah, it's, I mean, even considering the statistic, I mean, at some point it should be the correct one. It's not even exist here.
There's the same answer, I think.
I don't know why it's saying.
I'm nervous, teacher. Which should I answer?
Yeah, this is the most tricky one. Wow, by accident, everyone picked the right one. Yeah, it's the same. This was correct too. But it's still some people got it wrong. Congratulations. Okay. But yeah, so yeah, that's food sector. None. I think like 3 people, there are 3 people in this class. They automated the answering. Okay, just pick the right. It doesn't work that way, trust me. But yeah, none of them are immune to the rootkits. Yeah, we already mentioned they are very efficient. They are effective against non-malware, and they are the first line of defense. So it's all. So I go fast, so I can finish it. Yeah, I mean, when we're talking about advertisement, they use the click fraud to increase the click numbers and like gain profit. Yeah, I mean, you don't use click fraud to get your financial information, for sure. Okay, so the all is not answer, phishing. The last 2 questions. Anyone want to say why viruses, do you think viruses are more sophisticated? Huh?
Well, the nature of the viruses is just replicate in general. So basically, they don't imply communication among them because they just replicate. Besides, on contrast, all bots, for example, can communicate with the I forgot the name, the mother server, the mother server, the attacker server.
The bot master?
Yeah, the bot master. So in order to keep sharing information about or get information from the attacker and make action.
Yeah, that's correct, Alex. The last question. Oh, Last two questions. Anyone wants to argue why they don't need direct communication?
Because it's unsafe for the bootmaster. I mean,
Because what?
Because it's not direct communication, because the botmaster could be like easily tracked. So I mean, the communication is not straightforward end-to-end from botmaster to botnet. It goes redirected through some resources in order to get the orders. So
yeah, that can be one reason, or another reason can be there shouldn't be always communication. Actually, some bots can be like works like a logic bombs. You're affecting, you don't care how many you are affecting. At certain point, you want them to do these things at this date, at this time. Maybe you don't, basically you want to have it one-time use. This was the trickiest one. Actually, no, they don't. They won't be less likely if they use custom communication protocol, because the weirder they behave, it's easier for basically security companies to detect them. So the more normal they behave, harder to detect. The weirder they behave, like using some custom communication protocols, make it much easier to be basically to stand out, the traffic from them to stand out, because they're using weird stuff, weird communication protocol, which is not common. So they cannot blend with the normal traffic. They would be stand out. So that's it, guys. Take care. Who is the Ivan too?
It's me. Like the first account I used, I don't know why it started to bug a lot, and it even select an answer that I didn't know what it was. So I
Okay.
create another one. I don't know.
Okay. Take care, guys. See you next week. Next week we have classes in 2 days, Tuesday and Wednesday. And just for your information, you have class right now, 5:30. Okay.
Yes. Thank you.
Thank you, teacher. Have a nice weekend.
Take care, guys.
Thanks, teacher.
See you.